So today I am going to be talking about how to do an organizational network analysis in R using iGraph. So an organizational network analysis uses plots the connections between individuals in organizations. It gives you a visual output as well as a way to interpret the organizational network analysis numerically. So what this can be used for and is useful for is to visually see how people are connected in your organization, and another use for it is to see how information might be flowing through your organization, to whom or maybe who it's not getting to. So to start, I need a couple of packages for these. So I already have these installed, but I do need to library these packages so that they are accessible to me because I need to use the tools. So to do that, I will use library, and I'll be using iGraph and the Read Excel. I'm just going to run these. So it didn't really do much down here in my console because they're actually already libraried for me. I did that earlier. The next thing I'm going to do is import my data, and to do this I'm going to use the Read Excel function. What this does is I can tell R where to go to on my computer. So this is the path that it's going to use, and I'm just going to name the first one project and the second one staff, and I'm just going to go ahead and import those so I can talk about what those are. So in addition to importing the data, the second line right here allows me to view the data frame that I just imported. So the data in Excel was called ONA project, and I assigned it into the project data frame, and I did the same thing for the ONA staff, and I put it into the staff data frame. So here I'm going to look at the data, and in order to be able to understand how this worked, I kind of had to think about some teams that I'm on or that I know about, but since I didn't use every team that that I'm involved in, this is really not true data. It was just something for me to visualize this and group things together. So here I have the employees in the project. So in this first column, well, if you look at it by project, you see that there are 3 people on this project called STEM, and the relationships that those people have, these are the people that work together. So for example, Christina works with Patrick. Christina also works with Joe, and Patrick also works with Joe. And so those are the relationships with everybody on that project. And then it continues on. You see that the project called CS is has more people on it, so there are more relationships, and then it just goes on to explain those relationships with each other. Then in the staff data frame is just a list of the employees. I titled it participant, but it's a list of all the employees that are on all the projects in my project data frame. So next, I need to set the parameters for my ONA, for my organizational network analysis. To do this, I'm going to use the function graph from data frame, and this comes from the iGraph package. I'm going to name my ONA org network. And so this assigns all of these parameters to org network. So is the data for that takes the edges, and I need the edges to come from the project data frame. What the edges are the connections between the nodes. The vertices are, or the node, they're also known as the nodes, and those are going to be taken from the staff data frame. Here, the parameter directed, this variable is set to false. This can be set to true in other uses, and what this does is it puts directional arrows on the way the edges are linked, and this could be useful in another type of ONA that may be if you were going to look at the way information maybe is flowing through your organization. I'm not using that here. So I'm just going to highlight this and run this, and you can see here, so now in the environment, I have a new object, and it doesn't do anything for me until I plot it. So now I'm just going to plot the org network. And over in my plot area, you see that I now have the beginnings of an ONA. This is the most basic output that you can get with all the defaults that R sets for you, or iGraph does. So the way that I would interpret this is, you see that Patrick, Christina, and Joe have multiple edges connecting these nodes, as well as Sydney and Anna both have more than one connecting each other. And then there are many edges between all of these, but you see that Shane is out here with only one edge. Kevin is pretty far out here, as well as Matt. And by just looking at this graph, I would say that there needs to be some more integration and information sharing with these folks out here on the edges. And I would also say that it seems like a lot of Joe, Patrick, and Christina have a lot of things going on here in the middle and are probably pretty important. I would want to make sure that they are relaying information properly and communicating with these other people that are out here. So iGraph also does some other things. So in itself, this could be kind of hard to read. iGraph has some neat things. One thing that it can do, that you can do with it, is to change the colors of the nodes or the edges. I'm going to do that next, and by using this function here, this E is for the edges, and I'm going to change the edges of org network, and I'm going to use the variable color. And well, actually the function is ifelse. So here for the edges of org network, for the project variable, I'm using this double equal sign to indicate that I want the project CS to be green. And then I'm going to continue that. I want STEM FF orange and cans maroon 3. That is one of the colors that R can do. And then comma, this right here, this part black that's in quotation, this means everything else I want it to be black. So I'm going to go ahead and run that. And so it ran, but I need to plot it again. So I'm going to rerun the plot, and here you can see that it changed. This is kind of small, so you may not be able to see this very well, but I'm just going to make it a little bit bigger. So the reason that I indicated that these projects be colored and everything else black is I'm assuming that these are the most important projects that these people are working on, and so their relationships are all right here. So you can see that this green is CS, and Matt, Patrick, Joe, Christina, and Maria are all on it. They're all connected. uh, STEM FF is orange, and the same three people that are central to all the other nodes are on that, but nobody else. And then CANS, which is maroon, is down here, and these folks are on their own, and they're not connected to these other people who have the centrality. So that could be a problem. They might be working on their own. And then all the other projects are off here to the side. So these are the unimportant projects. And what the takeaway from this is that some of these people really need to be given some greater opportunities in the organization. They may need to be integrated into these other projects. We might need to see what's going on there, as well as this one. So that's one of the things that you can do with iGraph. In itself, this might not be useful, so you can, I decided to create a legend, and I did this here. So I'm just going to go ahead and run this, and it puts a legend up here. And so this legend, you see I indicated that I want it in the top left, and I use C to bind the three projects together, and then change the color, and these will go in the same order as the projects above. So the order is important. This line type, I indicated that I wanted it 1, which is the solid line, and this CEX at 0.8 indicates the size, so I can make this bigger or smaller. So this visualization is useful, but there can be some other useful information. So for example, there are different types of centrality, which the centrality of an ONA describes the position individuals have in relation to each other. So degree centrality is like the most basic. I'm going to run this for my organizational network, and the mode is all. And this shows the connections that everybody has. This is just the number of connections between one node and all other nodes. So as you can see here, Joe, Christina, and Patrick are at 8. So they have the most centrality, followed by Sydney, Maria, and Anna. And so once again, this shows us that Shane, Kevin, and Matt really need to be integrated a little bit more into these projects. Another type of centrality is closeness. So I'm going to run the closest for org networks, and what the closest tells me is this is the proximity of a node to all other nodes, not just the ones that are connected. So if you look at this, I can see that Joe has the most, his closeness centrality is highest. And then Maria, Sydney, Christina, and Patrick all come in second. The last type of centrality is betweenness, and this takes into the measure between the nodes, but it also takes into consideration, like, they don't have to be connected. Oh wait, yeah. It's just a measure of a node to all of the nodes. I might have said the closeness wrong. It's not just the connected ones, but this one is going to tell us the betweenness. And these numbers are a little bit different. It still shows that Joe has the highest level of betweenness centrality. Followed by Anna, who is here on our network. So that's interesting. Once again, you see that Shane, Kevin, and Matt are at 0, so there is no betweenness. They're not between anything, and they really need to be integrated. So thank you for listening. I hope that this was helpful.